Upon opening Unity, you will be presented with a default layout of Unity's most important windows. We'll do a brief breakdown on each window's function. The project window shows you your project's file system rooted at the assets folder. More importantly, it allows you to create Unity-specific files such as new materials, scenes, scripts, and etc. Files here can be selected in order to edit them in the inspector. And you'll notice that the file system directly links up with how the project is saved inside of your system. The console window logs info, warn, and error messages created by any script in your project. Think of it as where you would print Hello World in your first program. Most of the time, this window will be empty while you're not in play mode, but it is possible to get console output while just using the editor. The scene view is your view into your game's current scene as an editor. You can freely position the camera in this view. Compared to the game view, you will see gizmos and widgets within your world. You will be able to select special rendering modes such as wireframe or unlit mode, and you can also select game objects in the hierarchy by clicking on them in the scene. The game view directly mimics what your scene will look like when in play mode, and when your game is finally built. You will see the scene through the perspective of your scene's main camera. You can also use the game view to control your game when you are in play mode. The hierarchy is a very important window which shows you all of the game objects within the currently active scene. It will also show them in a hierarchical manner if your game objects are nested within each other. From this window, game objects can be inspected, renamed, reparented, and more. The inspector window is going to be your best friend. Any currently selected game objects or file in your project will show up in the inspector. From there, you will have the ability to edit all kinds of properties within them, as well as the properties of components for game objects. There are many more windows which can be spawned by using the window dropdown at the top of the editor, but they're usually not important enough to have docked at all times. The editor's layout can be reorganized in practically any way you desire. To do so, simply drag the tab representing the window to another location. You can split docks into two, tabulate them with other windows in a dock, or push them along the sides to create new docks. They can also, of course, be resized. If you change your layout, it may reset back to default the next time you open the editor. Therefore, you should save your current layout using the drop-down in the top right. Keep in mind you can save multiple layouts for different workflows. For instance, you could have a layout completely dedicated to animation or compositing. Here you can see my preferred general layout. I like to have a large dock in the top left for the scene and game view, and I like to move the hierarchy to the right next to the inspector so that I don't have to move my mouse across the screen every time I want to go back and forth. I also split the bottom dock into two so I can have the console visible at all times. In order to explore the other windows in more detail, we should add some game objects to our scene. In general, we use the hierarchy to do this. Right-click on any empty space within the hierarchy to get a drop-down menu of new game objects you can create. Pick 3D Object and create a plane. A new game object plane will appear at the bottom of your hierarchy. You may also have noticed the new geometry added to the scene view as well. Let's rename the ground by selecting it and pressing F2 to rename it. We would also like to create two new cube game objects and one new cylinder to the hierarchy. They will also be present in the 3D Objects section when you create a new game object. Rename the cubes to bottom and top and the cylinder to pillar. Now that we have some items in our scene view to give us a frame of reference, let's learn how to move our scene camera. To orbit the camera, hold down Alt, then click-drag your cursor along the scene view. This will spin your camera about an imaginary pivot point some distance in front of the camera. To zoom your camera, scroll with the scroll wheel or hold down Alt and drag with the right mouse button. Note that zooming in will bring you closer to the imaginary pivot point I mentioned before, so you can only zoom in so far. To pan the camera, hold down the middle mouse button and drag. Fly-through mode allows you to navigate your scene with flight controls. To start fly-through mode, hold down right-click in the scene view. While holding down right-click, you can move your mouse to change the orientation of the camera. Then, use W, A, S, and D to move horizontally, and Q and E to move up or down respectively. Holding Shift while using any of these buttons will allow you to move around faster. Lastly, when an item is selected in the hierarchy, you can press F with your cursor over the scene view to move your camera to the correct zoom and location to view the entire selected object. You can also do this by double-clicking on any object in the hierarchy. This is very useful if you've taken your camera on some wild adventure and need to find your scene again. Note that any new game objects spawned in the hierarchy will initially be created at your camera's pivot point, not at the scene origin. Let's use those primitive shape game objects we spawned in the hierarchy to create a basic level. Your scene view has a tool shelf, which gives you the ability to intuitively change a selected game object's transform. Select the Move tool, then select the ground plane. If you cannot see your ground plane, press F in the scene view to focus the selected object. You should see a large red, green, and blue gizmo somewhere on top of the plane. Clicking and dragging on any of the handles on the gizmo will let you move the plane in the X, Y, and Z axis respectively. If you would like some more control over your game object's transformations, take a look over on the inspector window while it is selected. All game objects have a transform component which dictates its position within a scene. The scene view tools are actually just a tool for manipulating values in the transform component. You can type in exact values for your game object's position, rotation, and scale here, which is very useful for making things line up perfectly. Traditionally, we like to keep our scenes centered around the origin point at 0, 0, 0, so let's actually zero out all the position elements in our plane's transform component. You can also clear out all transform values by resetting the transform component. We would like to make our ground plane bigger. In the Scene Views tool shelf, select the Scale tool. Drag the red X and blue Z handles to make the plane a bit bigger. If you prefer typing in the values, set the X and Z scale values of the plane to 2. Now, let's use those techniques to position our two cubes and our cylinder in the scene. You want to make the pillar a bit taller and wider. We also want to move it around a little bit and make it so it is resting just on top of the ground plane, but not intersecting through it. Note that you can hold down Control while moving something in the scene view to make it snap to a grid. This will make it easier to make it flush with the ground plane. We'd like to make the bottom cube a bit wider and also bring it up to rest on the ground plane as well. Then we want to move the top cube on top of the bottom cube. Let's also give the top cube a bit of rotation. Select the Rotate tool in the scene view. The gizmo for the Rotate tool looks a bit more complicated, but it allows you to spin a game object in 3D space. We will apply a little bit of Y-axis rotation to the top cube by clicking and dragging along the green ring. It's a little difficult to distinguish between the objects in our scene because they all have the same color. So let's try adding some colors to our primitive shapes. In Unity, materials are resources which describe how a 3D mesh should look when rendered to the screen. They handle things like color, light reflections, and special mapping. We just need to create some materials we can apply to our objects that will give them a different color. Things like materials are created in the project window. Right-click on the Assets folder and select Create Folder, and name that new folder to Materials. Note that this folder doesn't need to be called Materials to work properly, but we're just keeping things tidy. Click on the newly created Materials folder and you'll see an empty folder. Right-click anywhere in the empty space and select Create Material. We will call our first material Ground. In brief, materials allow the selection of special graphics programs called shaders, which will determine how any mesh they are attached to should be rendered. The default Universal Render Pipeline / Lit shader is a general-purpose shader using physically based render techniques to enable some cool interactions with light. The parameters you see available in the inspector are provided by the selected shader. An unlit shader would just have a base map parameter, for example. For this ground material, we will select the base map and change its color to a pure white. Click on the color bar and use the color wheel to do this. Great. Now let's create two more materials. Select the ground material in the project window and press Ctrl and D twice to duplicate two more materials. Call one of them primary and the other secondary. For our purposes, we will need to create a new material per each color we would like to use in our scene. Change the base map of the primary and secondary colors to two different colors of your choosing. You can use the outer ring of the color selector to change the hue of the color. We created materials, but we still need to apply them. You can drag and drop the material from the project window onto the target game object in the scene view or hierarchy window to set their material. Apply the ground material to the ground plane, the primary material to the top cube and the pillar, and apply the secondary material to the bottom cube. Notice that we reuse the primary material on two different game objects. If you go back and edit your primary material, you will notice the changes update in real time on both meshes. If you want, try messing around with the metallic and smoothness sliders on your materials to see how they affect them.